network and host. If we look at class B, a class B address has a default subnet mask of 255.255.0.0. Again, we said with class B, the division here is between the second and third octet, which is exactly where the difference is between the 255s and the zeros in the subnetwork mask. We look at class C, we see the same pattern again. So a class C default mask is 255.255.255.0. Again, this difference here between the 255s and the 0 corresponding exactly to where the division is between the network portion of the class C address and the host portion. So we can see that much. It's even more clear when we take these addresses and convert them into their binary format. If we do that, what we see is, for example, if I write that out in binary, this is that address in binary format. And then if I write the subnetwork mask out immediately underneath it, what I see is this 255 converted to binary is 8 ones. The remaining octets are all zeros, which means I have 8 zeros, 8 zeros, and 8 zeros. So there's my mask. And again, what I note here, where the dividing line is, which for class A is right there, is exactly where the ones stop and the zeros begin, in the subnet mask, in the binary version of the subnetwork mask. I can take this one step further and look at exactly how a router, for example, would process this, and what a router does to be able to figure out what the network actually is here from the IP address is it performs a bitwise AND all the way across on all the bits. And so if we do that, what we get, a line here, 0 and 0, 0, 0 and 0, 0, pardon me, 0 and 1, 0, 0 and 1, 0, so on and so forth. So I do that all the way across, and what I'm left with is this address along the bottom. And if I convert that back to decimal, what I'll see is something that looks like that. Now, in a stricter sense, this is what I would refer to as the network address for this IP address. This is the full format of the network address, 10.0.0.0. And I would say that this address, 10.0.1.10, is a member of this network with using this subnetwork mask. Now this is important, what we've done here, converting our address and mask into binary format, extracting, using those two, the network address, and seeing where in the bits, in the bit version, or the binary version of our addressing, for example, how we have a set of network bits, and how we also have as well a set of host bits. This right here, this fact right here is really important, and it's really kind of one of the starting points leading into subnetting. And that is what we'll get into in our next clip.